folks, I'm Ed Overstreet and welcome to the Night Sky Imaging YouTube channel. I am out again imaging, and I'm imaging the two targets that I was imaging last night, M106 and IC443. Is that what I'm imaging? The Jellyfish Nebula, yeah, and I keep forget, and M106. The night was pretty rough. I had to delete a lot of subs, and although I let it run all night, it was not a good night. The wind was awful. The guiding was horrific, and we still have wind. It's not as bad, but I'm going to take you over to the scopes, and we'll look and see what's going on again tonight. So, with that, let's head over there. Okay, we're going to share the screen and bring up the Jellyfish Nebula. I've got too much of a stretch going on here. There you go. It's looking pretty good. My sky glow's not nearly as bad as it was last night. Means around 1545. It was around 6,000 last night, which was just the sky glow from lights that were on in the neighborhood, and just overall pollution. But at any rate, things are looking better. Guiding's a little better. It was, if it's not messed up, it's at 6.64 RMS, so I can live with that. That's great for wide field. I can't screw up the stars with that kind of guiding, and I hope it lasts. But I was looking at the scene conditions, and they're bad. As a matter of fact, it's what they're rated as, bad. They get a little better around now, but they're poor, and it isn't until you get close to midnight that they become average. But the problem with seeing, it's usually an issue with planetary and solar and lunar imaging, more so than it is with deep sky. But if you have a bad atmosphere, if the scene conditions are not good, then your guide star is moving relative to your guide telescope and camera. It's twinkling, and that undulation just makes it hard for the guide camera to stay locked on, and the corrections that the software from PhD are sending are really bogus. The star may have moved due to the issues the mounts have, but it's also possible that the star is moving due to seeing, and PhD is trying to correct for that. It can't be done. Now, the advice from the folks that monitor the PhD forum, Bruce and so forth, they all say that if this is happening, then raise your exposure to 3 seconds for your guide camera, maybe 4, maybe 5 seconds, and that can help combat the scene conditions. Well, that may be true for most mounts, but for my Atlas Pro EQ, they're HEQ6 mounts. They're the same thing as the Skywatcher HEQ6. My mounts, I have 2 of them working tonight, and they both really respond better in bad scene if I lower my exposures. So with that being said, I'm going to go outside and let's take a look at the kits. This one's already started imaging, as you saw. It's on IC443, the jellyfish, and I'll have about 2 hours, maybe 2.5 more hours of data to add. I really didn't look at the data taken by this telescope last night. I did look at the data for M106, and I deleted quite a few subs. But I'm going to add to that, and hopefully I can get an image out of it. But I made some changes today. I redid my flats, and I had guiding issues. I had cables that were daggone, has it come out again? I had cables that were giving me a fit. I think I have it. I can't tell if that's. It should only be this. I'm not sure what this is coming out of here. Oh, I know what it is. It's from the. No, that's fine. I wish it was tucked in more, but that's okay. And I'm not sure what this is coming out. But at any rate, I rebalanced the mount, so I'm going to have to calibrate this. I may have to make another trip outside and see what's going on here, because the wind is acting up. If I raise the sound up, you'd probably be able to hear it like you did last night. It kind of screwed up the video, so I'm trying to keep that outside surveillance camera way down. Okay, let's do this. Let's go to the let's go to that SCT mount, not that one. That one's doing fine. Let's go to, it says Vixen, but it's not. It's the SCT, and let's calibrate it. So what I want to do is I want to find an area of the sky. I don't even care if there's a star there, because there's stars everywhere, but I want to find an area of the sky that's just to the west of the meridian, right here, that's about 0 dec. And so this is a good place to go, and it is at 0 dec. I'm down here, 0 dec. It's a perfect star, whatever that is. So I'm going to slew the telescope to this part of the sky, and that's one of the reasons why I like to keep a planetarium software up and running, connected to my telescopes, and it is connected. You can see down here where we're running EQ ASCOM, and I have EQMOD set up. This is my hand controller. It's a virtual hand controller, but I can control everything from adding my pet curve, which I just deleted. Need to run a new one, but it has all the information that you need to see when your scope is connected. I'm going to delete that, and then I'm going to go over here and I'm going to slew. Let me make sure I'm unparked. I am unparked, and let's go ahead and let's also make sure that my outside camera is up and working so we can watch it. Alright, it is. So let's go ahead and slew, and let's see if we can watch it do that. There it goes. So it's headed to 0 dec right at the meridian. Should almost going to be straight up. It's going to look almost like it's straight up, and it isn't, but it's going to look as though it is. Okay. So let's make sure we got PhD running. Do we? Nope. Let's loop this. And there's always stars. You don't have to find a star. Just find something to slew to, but you really don't want a bright star. This will work fine. So I'm going to have it pick a star, and then I'm going to hold down the shift key, and I'm going to click on this. By the way, I didn't know if you know this, but Dylan O'Donnell, an young Australian astronomer, developed this new green icon here that we click on, and I'm going to click on it. I'll hold down the shift key and gotta do it again. And it says, are you sure you want to force a recalibration? And I do. So we're going to recalibrate, and it's going to, down here at the bottom, it's going to move west first, and it's counting the steps, and this is the distance in pixels that it's moving. And if you look up here at the star, you can see it's moving, that's the direction west, although I don't know what west is or east is or south or north when I'm looking at this. And we're now 20 pixels away, and we're going to head back. So we're coming back this way, and then it'll go north and then south. But I did rebalance the mount. I took off the I was running flats, and they had so much stuff on them, I decided it's time to clean filters in the camera. So I put that back on, I rebalanced the mount, I snugged down some more cables, and which I have to go back out and look at. We'll see how the guiding goes before I head outside. As you can probably tell, I don't like to leave the comfort of my little world up here in my upstairs observatory. So we've moved north now 13 steps, and we're coming back. We got 26 pixels away, and we're headed back, and we'll see the star in a minute. It says this calibration is substantially different. Have you changed configurations? Well, I haven't, but I have changed balancing, major changes to balancing, so that might have something to do with it. Let's just see how we're going here. I may leave well enough alone because it appears to be getting off to an okie dokie start. I was going to run the guiding assistant. I will go ahead and run the guiding assistant. Let's look at the calibration data and see. I'm going to click on Tools, Review Calibration Data, and that's just my backlash. You do want to make sure that your deck line and your RA line are perpendicular. They're at right angles. And this is the backlash that you're seeing. Also, it's important that your RA rate and your deck rate is fairly close. And this is a little bit too far for my liking. I like it to be like maybe 12 and 13 or 10 and 11, but I'm not sure. I'm going to go ahead, and I may end up before the night's over with recalibrating this mount again. I'll pay attention to the guiding. If the guiding is okay, I'll leave well enough alone. But let's go ahead and run the guiding assistant. I do have plenty of time tonight if, uh-oh, let's see it going nuts over here on the end. But I'm going to run the guiding assistant, which is right down here. Again, it's under Tools, and go down to Guiding Assistant, and I'm going to click, and it automatically starts. This is the area where it gives you your time, and I pay more attention to this. I already know my polar alignment's going to be around anywhere from 1 to 5 arc minutes off when it finishes doing its thing. I really need to get out there and put the pole master on and polar line it again. It's been bumped a couple of times, and so it needs it. But I just kind of pay attention to the RMS values as this thing does its thing, and I'm going to let it run for 300 seconds or 5 minutes. That gives it plenty of time. And what it's doing is it's looking at the scene conditions, and it's uh, watching how the star behaves, and it's going to recommend then the uh, the recommendations it's going to make. I'm going to apply those. They'll show up right over here. And if you have uh, backlash compensation enabled, then you're going to get, I'm measuring the declination backlash, then you're going to get a readout of the value you should set your backlash comp to. And I always accept that. Now, you don't get a backlash compensation uh, recommendation for right ascension because the right ascension should always be engaged in one direction and moving in right ascension, and there shouldn't be backlash. There should be corrections just because of the worm and the gears, but there shouldn't be the backlash. But in declination, if you're 100% spot on polar line, then your deck curve should be flat. And the only thing that moves once you're on your target is your RA. But this is the perfect world, and it isn't a perfect world. So when the deck gear stops and then starts, it has to engage, and sometimes it takes it to work out the slack. It takes it a fraction of a second, and that is backlash, and so it doesn't respond or react as fast as one would like, and that backlash, that drag, is reflected in your deck curve. So this helps to make this helps to make that whole process of declination, your running of your declination work better by kind of factoring in the backlash compensation that you need in order to get good guiding out of deck. I think it works. I've had times when everything worked out perfect here, and I still had deck issues. But at any rate, it looks like my polar alignment is really, and it isn't. I know it isn't because last week at this time I ran it and it was around 4 or 5 arc minutes off, and 2 nights before that it was like 1.5 arc minutes off. So I think it's a little bit software related, but again, I'm going up to 300 seconds. Let's go back while that's doing that, and let's take a look at the wide field setup and see if we've ran into any guiding issues. This is the guiding PhD. This is a replication provided by Sequence Generator Pro of what's going on with my guiding, so I really don't have to go back and forth. I can tell from this that we really are dealing with essentially the same guiding. It's around 70 RMS, and that's fine. My deck curve is pretty flat. It's at 39 RMS. So I'm not complaining. I'll take that all night long. But let's head back to running our guiding assistant. I may be that far off in polar alignment, because I may just have no option but to, what's tomorrow night look like? Let me take a look at the weather tomorrow night. I may just do that tomorrow night, work on getting that. That's what I'm going to do. I won't be able to image tomorrow night because by 11 o'clock, it's going to be bad. Is it going to rain? Nope. It's just going to be bad. So Monday, tomorrow night, it's just going to be bad. So maybe I can get the polar alignment knocked off and may run a new set of darks while I'm out working on it for both kits. I need to run March darks anyway, and flat darks. I just did a new set of flats, and I need to run some flat darks. So that's what I'll be doing tomorrow night. Okay, we're at. I'm going to stop here. Yeah, I do have some polar alignment issues. Okay, let's let it do its thing. It's measuring the. Are taking the values, and it'll take it a few minutes, and while it's doing some solves, I'm going to head back and I was going to show you, let's see, Pixinsight. I'm going to go up to script utilities, and I'm going to run auto color. I have I've combined the red, green, and blue channels in Pixinsight. This was the M106. This is what I did. This is what I have so far, and I was wanting to look at it, and I did a crop. It's a very slight crop, and I ran dynamic background extraction, and so I just ran multilinear transformation, which is a smoothing algorithm, and now I'm color calibrating it using Hartmut-Bormann's auto color. It does a pretty good job. I either use that or photometric calibration, and while it's doing that, we'll go back. Well, we still haven't. Here we go. I know it's going to tell me the polar line. Yeah, polar alignment error. Try using the drift alignment tool to improve alignment. Well, I'm not going to do that. It's recommending between 1 and 3 seconds for your exposure. Set RA minimum move to 10. I kind of figured something along that line, and deck to 15. And it says try setting your backlash compensation to 700, and I'll do that. So show backlash graph, can't say it. And so there's the ideals, the white dots, and the red line here is the measured backlash. The difference between the white and the red is the slack, and then it finally gets closer and picks up. Okay, well, it is what it is. Now, what I'm going to do is I'm going to stop guiding, and I'm going to make sure I've got the outside camera. It's already shut down, so I can watch it slew. And while it logs on, I'm going to go into Pixinsight, and I'm going to click on 106 because I'm going to slew to it now. And let's take a look at this. M106 is pretty low in the sky, and I don't expect the images to have a lot of clarity. Oh, it is. I know what that is. That shouldn't be hanging out there. Okay. Yeah, I'm gonna have to go outside. Okay, we are in the neighborhood, so let's center it, and we're going to plate solve. And what plate solve does, it will take a picture of the sky where the telescope is now pointed, and it will compare that sky with a catalog to determine exactly where it is. And if the target M106 is not, I'm going to have to solve before this is going to solve. There's M106, but I am not in focus. So I'm going to spend some time taking care of that. There's no point in trying. I'm so far out of focus. So let's bring up image statistics, and let me move this up here. And let's take, let's get frame and focus, and let's take an 8-second image. I move so many things around, I'm not surprised I'm not in focus. Alright, let's try going, let's say change the step size to 10, and let's try going out 20 steps and see if that improves it. I'm going to get close, and then I'll use autofocus. I don't know if it did or not. Let me go out to another 30 steps. I think that's worse. So let's bend this, and let's go in. Let's try here. We were at 1,000. We're at 930 now. That's moving in the right direction. Let's go another. Let's go down to 900 steps. A little better. And let's take another. Still a lot better. The half flux radius is 1.75. So what I'm going to do is I'm going to stop there. I'm going to trick my focuser, and I'm going to see if I can't, I'm going to turn it off. I'm going to bring it up, my driver. See if it'll come up. I'm going to set the position. No, I'm not. I don't want to change that. Let's just go ahead and run Focus Assistant. Didn't turn it back on. It makes it hard to start it. Okay, let's go ahead and run it. So what it's going to do now is take a series of pictures, and it's going to defocus it. So it's already ran it out to 1170, so I'm going to have big stars. It's going to take a picture, and then it's going to come back in about 100 steps. It's going to take another picture, and they should get smaller, and it'll make note of that, and that's where it is on the half flux radius graph. It's about 8. If If you look over here, you can see where it's at 8. And it's going to take another picture. It's gone down to going to drop a lot now. No, it didn't. I thought it would. So 77 is going to be pretty close to the, so evidently that wasn't really close a while ago. It's going to start defocusing in the other direction now. And it's going to be 661. And it has solved. So it's set it to 661. So what I want to do now is I want to plate solve it. I'm going to go ahead and slew again. It's not too far off, and now we'll plate solve. And so it should solve it on the first attempt because it's fairly close now. When you do these things live, stuff happens every time. And stuff's happening now. I'm off 1,000 pixels in RA and 435 in DEC. I thought I'd be closer. Yep. Well, I hope the wind dies down. Wind and bad scene just do not make for good guiding. Okay, we have a successful plate solve. We're 21 pixels off in RA and 11 pixels off in declination. That's fine. If I come back out and plate solve again and add more to this another day, I'll get as close each time, which makes it nice to be able to do that. Let's go ahead and start PhD and start looping. Let's find a star. Not looping yet. Okay, let's find a star and let's cross our fingers. We are now guiding. Oh boy. I'll tell you what I'm going to do while I'm thinking about it. I'm going to bring up EQMOD and I'm going to run a pec curve. In order for me to do that, I'm going to rotate through my display by clicking here. And so here's where I'm at. I'm going to make I'm going to go through my gears 9 times, my worm gear 9 times, and everything else I'm just going to leave. I don't need a timestamp. Everything else I'm going to make 9 passes. It's going to take about an hour to do 9 passes, and I'm just going to record. I'm going to go here and click on record, and it's going to start recording the behavior of the gears in my mount. And when it's done, it will automatically load that into EQ mode and apply corrections to help PhD along. So right now we're capturing 25 of 4,311 um, events, cogs, I guess, gears. Somebody will correct me. What is it? 4,311 whatever. It involves the cycle, the 9 cycles. So 9 going into this is how many, whatever it is, in a cycle. So it starts recording it, and you'll see the graph eventually take shape up here. Okay, and it can do this while I'm guiding, so I'm going to put this to sleep, and guidings looks, I can live with it. I wish it was better. Just hopefully it doesn't get worse than it did last night. So let's go back and let's start our start imaging. So it's validating connections and doing its thing. I don't know what it's doing. Never takes this long. I think it's just going to cause me some grief because I'm live. I can't watch it. I don't know. I'm not getting my graph up here. I'm going to stop this. That was messing me up. Oh, it couldn't. I'm doing a P. Why am I doing a pet curve? I've lost my mind, guys. Why am I doing a pet curve when I know it's going to have to slew and recenter? So at any rate, I'll start it again in a minute. Tell you what I can do. The other one needs a new pet curve too. So I'm going to head over to the other kit and bring up, cycle through, and let's start recording. I also have this set up for 9. When I run one of these curves, I invariably run it for 9 cycles. Let me stop that. Let me go to my last pet curve that I ran, which was 1213. Yeah, 1213. Let's load that. And so here was that curve. And loading that created an issue. That was nice. Here we are right here guiding. But I want to run another one, so let's let it rip. It's on its way now. Okay, let's head back to the other, which should be I don't need that. I need this one. All right, we are imaging. It already replate solved, and we're taking our first blue filtered image for 180 seconds, and we have 127 seconds left in this first image. And this is an image from plate solving, and let's go back over to Pixinsight. We've color calibrated this, and so I'm going to go up here to Easy Processing Suite. Let me do this first. I want to change this to MLT for multilinear transform, and then I did a auto color, and so I want to save that as the last thing I did. And now I'm going to stretch it, do a permanent stretch, and I'm going to use script, easy script. I like their soft stretch, and we're going to run this. And let's run it. Most of the time I do a manual stretch, and but I really like the way this does the stretch. I still have some gradients up here, and I'm going to remove those, but I'm going to remove the stars first. So I'm going to change the name of this to, I got a lot going on tonight. I'm going to change the name to this to EZ Stretch. I know what I did. I'm going to save it, and I'm going to take this over here, and then I'm going to change this name to Starless, because I'm going to bring up StarNet. I don't want that. StarNet. I'm going to create a star mask, and I'm going to drag this over here and let it do its thing. In the meantime, I'm going to go back and see how my first image is. This is image number 1, and see how the guiding is going. Well, it's at 152, 149, and I wonder if you can see this guide star up here changing the lights. You see it's not just moving. The guide star it gets brighter, and dimmer, and brighter and dimmer, and its shape is changing, and that's just all scene related between 1 second. So every 1 second it's taking an image, but you're also seeing every 1 second how the guide star is changing in luminosity. It's not just the movement part of it. It is moving, and it's getting corrections, but the whole guide star's wobbling on me just due to scene. I accept that because I know that's going on. Then what becomes hard for me then to understand is that over here with the other telescope, it may have changed, but my guiding is still in the 70s. So it's a lighter scope, and it's a Lodestar. Both of them are using Lodestar cameras. Both of them are using Orion 60 millimeter guide scopes. So all of that's identical. The mounts are absolutely identical. Well, they're not. They're the same make, brand, but the insides of them are not identical. They're not machined exactly the same. So although they're belt driven, there are differences. But what then I can't explain is sometimes the other mount is doing better than this one. So it might be where it is in the sky. That can have a lot to do with everything, but it's just kind of hard to explain sometimes why these things do what they do. And it even makes it more so when you're running two at a time and you're usually never getting the same exact guiding. I don't care how good it is or bad it is. One's usually doing better than the other. So, but rarely am I in the same part of the sky because I almost always try to image several different targets and take advantage of the fact that I do have two kits that I can run at the same time. So let me go outside and let's kick the camera on again. See, one's going uh, west and one's shooting east. So this is already west of the, this is east shooting west, so it's already past the meridian. This is not. Uh, this will end up having to cross the meridian probably around 2 o'clock. But so this could have something to do with it. It could have something to do with the fact that the wind is blowing and the direction that it's blowing from may have more of an effect. So I don't know. I just have fun trying to figure it out and doing this. I'll try to let me get rid of this. Okay, let's go back to. Oh, I wonder if it's finished running StarNet. Takes a while to do that. And nope, still doing it. It's only 22%. Okay. See how, look at the sky glow from this image. It's at 7,485, the mean. And if you'll look down here where I hit on pixels, you can see when I move around that the sky is just, it's lit up. And then if we go over to the other kit and take a look at this guy, it's in the 23, 24, and I could be running over a star. Let's do a we are high stretch, and let's fit the screen. We're doing some oxygen now. There's just not a lot of it in the jellyfish, but there is some. And right here, and there's some right here. I doubt you can see it, but there's enough, and I want it, and I'm going to accumulate it. But there is some here and here. So we're out to get some so we can add it. So we're right here. The event triangle's pointing to here. We're at 15. We want we're at 11 images. We want 15, and then we're going to roll back over to sulfur. And this is where I stopped it last night. I didn't get the 20 that I wanted. I have about an hour and 20 minutes left, and if you take a look, you can see that I've got an hour here and an hour here. I have about 2 hours left. I'm going to stop this though, and this is going to stop automatically at 12:30, and then it's going to, I'll be in bed, and then this target's going to start at 1:10. So at 12:30, it's just going to stay waiting until 1:10, and then it's going to slew to M92, which is a globular cluster, and it's going to take 10-second images, 100 each. It's going to take about an hour to do that. Then it's going to go to a dark well, it's not a dark nebula, it's a bright nebula. It's IC4592, and it just barely, it's going to be real low in the sky, but it'll be dark enough, I hope, and it's over the darkest part of the my neighborhood. It's towards the mountains, and so I'll be I'll show you how. Let me see if it shows you. Yeah, there he goes. It's going to start about here and end about here, so I'm only going to have like 1 hour, 2 hours to image it, and I'm going to have to add it on as I can, but I'll close this out and I'll show you what I hope to get. I hope to get 10 180-second HA and 10 240-second O3s and 10 120-second S2s. I have an hour and 30 minutes planned for that. So we'll see. That'll take me up to about 5 o'clock in the morning, I think it is, and 3 targets. I'll sleep while all that's going on, and that's one of the beautiful things about Sequence Generator Pro. There's a lot of things I love about it, but that's one of them. Yanni seems to be doing good on this one, and so I'm as happy as I could be with what's going on with this kit. See, go back over to the other kit before we head over to okay. We're at 12 seconds, and we'll take our 5 seconds, and let's look at our second image. We had probably an airplane. There's probably more of it you didn't see, which is fine. I'll calibrate it out of it. So there's a galaxy down here. I framed this so that I would be able to see this galaxy and this galaxy down here. I didn't want to center it because that would put this galaxy too far to the edge, and if I had to crop, I might lose some of this. So I have the galaxy framed just a little bit up and to the left in order to get both of them in. But this is primarily what I'm looking for. So let's go back over to Pixinsight, and we are still running. Oh, one of the reasons why this is taking longer than normal is I'm trying something. I always drizzle my images with my wide field kits because they're so undersampled. And the Smith Cassegrain that I'm using for this with the ASI 1600 is slightly oversampled. So logic tells me you don't drizzle. But I did look at the data from a drizzled image and one that wasn't drizzled, and honestly, the drizzled image was so much superior, the stars looked so much better, that I went ahead and drizzled all the channels LRGB, and but the file size is 2 times more than what it was because of the 2x drizzle. So it takes a lot longer for each of these steps to run. I mean, a lot longer. That would have been done a long time ago if I had not drizzled this image. But it's worth waiting. Alright, let's go back. And I think I'm going to call this live imaging session done. Is there something else I was going to do? Let's see. We'll check our guiding. I know it's not great. 134. Here's what I'm primarily interested in though. If these two numbers right here, 97 and 93, if they're close, if they're similar, then my stars will be round, regardless of this number. This needs to be lower because the image scale for this camera is 0.52. This really needs to be around 0.52 to have tack sharp stars. But as long as these are close, they'll be round. They'll just be bloated. And that's the difference. And if this happens to be 1.7 and this is 1.0, then they'll be oblong. So if you can keep these two numbers similar, then you can avoid the oblong stars. Go ahead and sleep. We don't need you now. So that's important to make note of. Okay, we have 2 down, and we're going to go to 75. We have 6 hours and 23 minutes remaining. And I know we've got plenty of time because we're right here. So we have 1 hour, 2, 3, 4, 5, 6, 7, 8 hours, and I need to be stopping about there. So there's 8 hours of available imaging time. So I shouldn't have any problem getting all 6 hours and 22 minutes in, provided I don't get hit with clouds or have equipment failure. So I'll head off to bed probably around 11:30 or 12. This will still be going. And my plan last night was, if I could image all night and get some good images, tonight I was going to add a few more, and I was going to start on the needle, which is 4244 Galaxy, the Silver Needle Galaxy. And so that was my plan. I'll do that another day. Let's look at the Pegasus Powerbox before I go. It's 53 degrees out, and the dew heaters are off. They haven't been turned on yet. Let's see. And the reason why is that as long as the temperature, which is in red, which is dropping, and the dew point, which is this blue line, and this is the relative humidity. This is going up. It always goes up throughout the night. But as long as these two don't converge, then there's a good chance I won't have any moisture accumulating on my cameras, my lenses, and my equipment, the grass, everything outside. So no dew, in other words. And if it looks like these are going to start converging, then right before they do, the Pegasus Powerbox will automatically turn my dew heaters on, and they'll run it, and they'll turn them up to there's various levels, and it will turn them up automatically. I got it set on auto down here, and it will turn them up as much as they need to keep dew from forming, and they work like a charm. My camera is drawing point almost a little over half an amp. That's nothing. We call that very energy efficient, but all it's doing is running a fan. That's the only thing that's powered on these astronomical cameras, is the fan, the tech system. The mount is just tracking, and it's at 0.77, 0.78 amps, and the focuser isn't doing anything, but even in idle, it's 1/10 of an amp. So this whole thing is only pulling 1.7 amps, so there's no current really being drawn at all. That's pretty cool. I can always, in the past, before I had the Pegasus power boxes, and by the way, I have 3 kits set up outside, 1 for solar and 2 for deep space. and I have these boxes on all three of them. They're worth their weight in gold, in my opinion. Uh, but when I have COM port problems, I can just recycle the COM port and uh, you know, start up, shut down and start up your computer, recycle the COM ports. It's like new. Works like a charm. I can use this to run autofocus. I just don't have it set up. This is the power graph. This shows the voltage being used, and this is the amperage. Amperage, current, they're one and the same. And so I was probably slewing during that time. I was probably slewing. Something else was turned on during this time, and it stayed. We're pulling more. Now this goes back to 7 o'clock when I first turned everything on. So nothing was really, for a while, nothing was working. So at any rate, okay. Well, folks, it looks like guiding has settled down a little bit. It isn't any worse. Let's see what it is. It's at 132. I'm going to have to live with it. We're at 89 and 90. So stars around, a little bit big, but I got to deal with it. And the half flux radius is running 1.79. And that's not bad. I am, nope, don't want that. I want to show my FITS header. I'm at 200 gain, and which puts the electronic gain around 0.5. I'm doing that so I can take shorter exposures because I got the moon coming up, and I'm not prepared to take 5-minute exposure with this SET. Okay. Well, folks, I want you to have a great rest of the evening and a great week. And if you have clear skies, go shoot something and let me know how it turned out. So have a great one, guys.